Imagine, for a moment, that everything you know, the earth beneath your feet, the stars overhead, the vastness of space itself, is actually contained within an immense, inescapable cosmic structure, a black hole. At first glance, the idea seems outlandish, almost like the plot of a science fiction novel. But as we journey deeper into the realms of modern physics and cosmology, we encounter theories that challenge our most fundamental assumptions about reality. Could it be that the universe itself is a black hole, an all-encompassing gravitationally bound region from which nothing, not even light, can escape? As mind-bending as it sounds, this theory is rooted in some of the most cutting-edge ideas in science, and exploring it offers a fascinating glimpse into the mysteries of the cosmos. To truly appreciate the depth of this theory, let's start with the basics. Black holes are among the most mysterious objects in the universe. They form when massive stars exhaust their nuclear fuel and collapse under their own gravity, creating a region in space where gravity is so strong that nothing, not even light, can escape its grasp. The boundary that defines this region is called the event horizon. Anything that crosses this invisible line is lost to the outside universe forever, swallowed by the black hole's insatiable pull. Now, consider our universe on the grandest scales. We inhabit a cosmos that is vast beyond comprehension, filled with billions of galaxies, each containing billions of stars. For decades, scientists have pondered the ultimate fate of the universe, its origins, and the laws that govern its evolution. Two of the most successful theories in physics, Einstein's general relativity and the framework of quantum mechanics, describe the universe at very different scales. General relativity explains gravity and the structure of space-time, while quantum mechanics governs the realm of the very small. Yet when we attempt to merge these theories, especially in extreme environments like black holes or the very early universe, the mathematics becomes tangled and our understanding falters. This is where the idea of the universe as a black hole enters the scene. Some scientists propose that the universe itself could possess an event horizon, just like a black hole. Within this boundary, everything we observe, the galaxies, the cosmic microwave background radiation, the very fabric of space-time, would be contained, unable to escape to any outside region. But what evidence or reasoning could possibly support such a radical idea? Let's delve into the cosmic clues. First, consider the expansion of the universe. Since Edwin Hubble's observations in the early 20th century, we've known that galaxies are moving away from each other, suggesting that the universe is expanding. This expansion is not slowing down, but accelerating, driven by a mysterious force known as dark energy. If we extrapolate backward, we arrive at the Big Bang, the moment when all matter and energy were concentrated in an unimaginably dense state. In some ways, this initial singularity shares characteristics with the singularity at the heart of a black hole, a point where our current laws of physics break down. But the similarities don't end there. The cosmic microwave background radiation, the faint afterglow of the Big Bang, shows remarkable uniformity across the sky, implying that distant regions of the universe were once in close contact. This observation is difficult to explain without invoking a period of rapid inflation, a brief epoch when the universe expanded exponentially faster than the speed of light. During this phase, space itself stretched, smoothing out any irregularities and setting the stage for the universe we observe today. Here's where things get really interesting. Some models of inflation suggest that our universe could be just one bubble in a much larger, perhaps infinite, multiverse. Each bubble would have its own physical laws and constants, separated from others by vast, unbridgeable gulfs. In this context, it's conceivable that our universe's boundary, the edge of our observable region, could function much like the event horizon of a black hole. From the inside, we can never observe what lies beyond. We are forever confined within our cosmic bubble. The holographic principle, a revolutionary concept in theoretical physics, lends further support to this idea. Originally developed to resolve paradoxes in black hole physics, the holographic principle suggests that all the information contained within a volume of space can be encoded on its boundary, much like a hologram. In other words, the three-dimensional universe we experience could be a projection of information stored on a two-dimensional surface, the event horizon. This principle has profound implications, not just for black holes, but for the universe as a whole. If the universe itself has a boundary, then everything we perceive, matter, energy, even space and time, could be a kind of holographic illusion. Recent discoveries in astrophysics and cosmology have added fuel to the debate. Observations of the universe's large-scale structure, the way galaxies are distributed across cosmic filaments and voids, have revealed subtle anomalies that defy easy explanation. Some researchers argue that these patterns could be the fingerprints of a universe shaped by the same forces that govern black holes. Additionally, studies of the cosmic microwave background have uncovered slight temperature fluctuations that hint at processes occurring near the universe's edge, whatever that might mean. But perhaps the most tantalizing evidence comes from the study of entropy, the measure of disorder or information content in a system. In black hole physics, the entropy of a black hole is proportional to the area of its event horizon, not its volume. This counterintuitive result led to the development of the holographic principle. When we apply similar reasoning to the universe, we find that the amount of information that can be stored within our observable cosmos is also limited by its boundary, not its interior. This striking parallel suggests a deep connection between black holes and the universe itself. Of course, the idea that our universe is a black hole raises profound philosophical questions. If we are trapped within a cosmic event horizon, what lies beyond? Is there an outside to our universe, or is the concept itself meaningless? Some theorists speculate that black holes in our universe could give birth to new universes, each with its own space-time and physical laws. In this scenario, our universe might be the offspring of a black hole in another, larger cosmos, a cosmic Russian doll, with universes nested within universes. This perspective challenges our understanding of causality, determinism, and even free will. If everything that happens within the universe is encoded on its boundary, does that mean the future is predetermined, like the unfolding of a holographic image? Or do we retain some measure of agency, even within the confines of a cosmic black hole? These are questions that stretch the limits of science and philosophy alike. Let's take a step back and consider the broader implications. If the universe is a black hole, then the ultimate fate of everything within it, stars, galaxies, life itself, might be governed by the same laws that dictate the life cycle of black holes. Over unimaginable timescales, black holes evaporate through a process known as Hawking radiation, gradually losing mass and energy until they disappear. Could the universe itself undergo a similar process, slowly fading away as information leaks out across its boundary? Or might it collapse in a big crunch, only to give birth to a new universe in a never-ending cycle of cosmic rebirth? The idea also forces us to reconsider our place in the cosmos. For centuries, humanity has grappled with questions of meaning and purpose in a vast, indifferent universe. If we are inhabitants of a cosmic black hole, does that diminish our significance, or does it imbue our existence with new mystery and wonder? Perhaps the very act of questioning, of seeking to understand our origins and fate, is what defines us as sentient beings. Despite its allure, the theory that the universe is a black hole remains highly speculative. It is a testament to the creativity and daring of scientists who are willing to challenge the boundaries of knowledge. As research continues, New observations and experiments may shed light on the true nature of our universe, either confirming or refuting this bold hypothesis. Yet, even if the theory proves incorrect, the journey of exploration it inspires is invaluable. By questioning our assumptions and probing the deepest mysteries of existence, we expand the horizons of human understanding. The universe, whether a black hole or something even stranger, invites us to marvel at its complexity and beauty. In summary, the notion that our universe could be a giant black hole is more than just a wild idea. It's a serious scientific hypothesis that draws on the latest discoveries in cosmology, quantum mechanics, and theoretical physics. From the parallels between the event horizon and the cosmic boundary, to the insights of the holographic principle, to the enigmatic patterns observed in the large-scale structure of the universe, the evidence is intriguing, if not yet conclusive. What does it all mean for us? Ultimately, the quest to understand the universe is a reflection of our deepest curiosity. Whether or not we are living inside a cosmic black hole, the search for answers drives us to explore, to imagine, and to dream. The universe remains a vast and mysterious place, full of surprises waiting to be discovered. So, as we contemplate the possibility that our universe is a black hole in disguise, let's keep our minds open to new ideas and possibilities. The cosmos is stranger than we can imagine, and the journey to understand it is only just beginning.